Bismillah Rahman Rahim. My name is Dr. Zubair Ahmad Kalhoro. Today we are going to learn about function and their graphs. You already know about function from high school, college level, and their graphs. Now, what is function? What is definition of function? Actually, function is a special type of relation. And again, what is a relation? Any subset of Cartesian product called relation. You also know the definition of set. A set is a well-defined collection of distinct objects. This is a simple definition of set. If you take two sets A and B, then you write A cross B. A cross B means Cartesian product of A and B. Then their elements, all elements of set A, all elements of set A cross B in order pair form. Your first element belongs to first set, second element belongs to second set.
45 cents ले रहे हैं ऐसे चेक आएगी ना
Then every element of Cartesian product is a relation between two sets A and B. Means relation between A to B. Now consider two sets X and Y and the relation between their elements is shown below. Now this is the first relation between X and Y. F is a relation between this set to this set. X whose elements are A, B, C and D. Y is another set whose elements are U, V and W. Now here A is mapping to U, B also mapping to U, now and C mapping to V and D mapping to W. It means image of A under this relation is U. Again, image of B under this relation F is also U. And image of C under this relation F is V. And image of D under F is W. It means in X, every element has only unique image. Image of A is U. Image of B is also U. Means A's image is unique. Not A is two images just like U and V. B is two images, maybe U, V, W. Every element of A has unique image. In this example, first example. Now again take another relation G. Again X has element A, B, C, D, and Y, X, Y, Z, any three elements. Now here A is mapping to X, B also mapping to X, C mapping to Z, and D also mapping to Z. This is another relation G. Now see here, now from the about two examples, two figures, we see that the relation F and G maps each element of X into a unique element of Y. Again, see here in second, here A map X, it means A's image is unique X. Again, B image also X, this is also unique. C image also Z. One image, only unique image. D image is also Z. It means image of any element of X is not repeated. But here is some element in Y, they are not mapped, so no problem. Main thing in X, every element of X map to any element of Y, but it must be unique. Means if X has 3 element or 4 element, means 4 element must be mapped to Y, but image must be unique. If such type of relation is called function. Now in both examples, here every element of X map into a unique element of set Y. It means here both X and first example number 1 and 2 means F and G both are the function. Now again see H is a relation. Here A is mapping to W, B map also W, and B also map X. It means B has 2 images. One image is W and another image is X. It means B has not unique image, 2 images. Again C map to Y, D map to Y. It means one element in X whose name is B, who has 2 images. That's why this relation, this H is a relation but not a function. For what is the condition for function? Every element of X has images. Yes, this is true, A, B, C. But every element of X has unique image. B has not unique image. That's why H is not a function. Again check K. Now again in K, A mapping to W, B mapping to X, C mapping to Y. But here is one element D in X who has no image. But there is a condition, every element of X must image, but image must be unique. Again, K is also not a function, but this is simple relation. And see here, in a relation H, it maps one element of X into 2 element of Y, just like B. Again, in relation K, it does not map one element of X into any element of Y. It means last element. Then we say that F and G are function, but H and K are not function. These are only relation. Now we come to normal definition of the function. What is function? Function is a relation between two sets X and Y. X and Y both are non-empty sets, means there must at least one element. A function is a relation between two sets X and Y which maps each element of X into a unique element of Y. In a set, there are two things are important. Every element of X must be mapped, but every element of X map into unique element of Y. Then such type of relation is called a function, and we write in this way: there is a set X whose element is small x, Y whose element is small y. Apply a function, apply a rule. This is a rule F. This rule is called a function. What is rule? Every element of X map into unique element of Y. This is a rule. This rule is called function. Or mathematically you can write this F. How we read this? F is a function from X to Y. Or if X, this X, apply rule F, we write F of X, we get Y. Or simply Y equal to F of X. Y equal to F of X. Now Y equal to F of X is a function, and here there are two variables. One variable is Y and another variable is X. Y and X. This X is called independent variable. Means those variable from the set X is called independent or input, and Y is called dependent variable, or this depend upon the X. Whatever you put input X, you will get output. Output depend upon this input. This is independent variable, this is dependent variable. Now example, y equal to x square plus 1, y equal to sin x plus cos x, y equal to e raised to x plus log x. These are the example of the function, and this function is also called explicit function. Explicit function means here y is one side and x is another side, means dependent and independent variable both are separated. But implicit function, both variable combined together, just like x square plus y square equal to 2, x square plus sin y equal to 3. Such type of function is called implicit function. Okay, now we come to some basic concept of interval. What is interval? Subset of a real line is called an interval. It means you take any subset of real line, and there are different intervals. Usually we are using open interval, close interval, half open, half close interval. Now the notation, this 2 is in parenthesis, 2 5, or this 2 5 can be written in this form. 2 and 5 is used to denote the open interval. Open interval means small parenthesis. Here ending point is not included. Here is written 2 5, it means numbers between 2 5, just like 1.99, 1.98, 1.5, 1. Okay, means between 2 and 5, means less than 5 means 4.9, 4.5, 4, 3, and 2.5, 2.001, means ending point are not included in open interval. All numbers between 2 and 5, not necessary integer, all real numbers. It means between 2 and 5, maybe 2.001, 2.5, 2.8, 2.9, 3, 3.5, 3.8, 4, 4.9, 4.99. This is open interval. The endpoints are not included, and mathematically write open interval a b is set of all x such that a less than x, x less than b. It means this x, all those number of x, a less than this x and b less than this. It means a and b are not included. Between a and b, all elements present in the set. Just like write 2 is less than or equal to x, x less than or equal to 5 represent a closed interval. In closed interval, ending points are included. One in which the end points are included, the interval is usually denoted by 2 5. Now here 2 5 means starting from 2 ending up to 5, means 2 also here, 2.5 also here, 3 also here, 4, 4.5 up to 5. If here is an open interval, then ending points are not included. And mathematically you can see that here closed interval set of all x such that a is less than or equal to x, x less than or equal to b. This is closed interval. And see here, this is half open, here half open and half closed. It means this point not included in this interval, but b also included, means except a bit from b to downward a, just like 2 and 5, 2 not included, 2.5, 3, 4, 4.5, also 5, just like this. And half close, this a point is included, but this is not included. This is half open and half close interval. Now very important thing, very important concept for domain of the function. Domain of the function means how we decide. Suppose we have any function y equal to f of x, then what is x? X is real number or x belongs to integers or x belongs to whole number, what? Then domain of a function denoted by df is set of all real values of the set x for which function f of x is not infinity, f of x is not imaginary. It means what is domain of the function? You know that y equal to f of x, the function x is domain, y is codomain and range. Then domain of the function is what? Set of all real values of x. It means you put any real number in place of x, but if for it, when we put any real number on x, you should remember f of x not infinite and f of x not be imaginary. When any function is infinite, when 1 upon 0, anything upon 0 is infinity. And when is imaginary? When under radical you put negative sign, then radical negative sign, we get imaginary number. It means domain of any function set of all real values of x, but you should care function not be infinity nor be imaginary, except infinity and imaginary all are the domain of the function. Now find the domain of the function given below. Suppose here f of x equal to x squared plus 2. Now since f of x is not infinite, why? Because this is not in fractional function, not denominator or numerator. If you put, it means f of x never be infinity, because infinity also come when anything upon 0. It means you put any real number, again result will be finite and not neither infinity nor imaginary, because this function not in radical. If function is given in radical, then there is a chance of negative sign inside the radical. So domain of this function is set of all real numbers. If you put any real number, again result will be not imaginary nor infinity. It means domain of this function is set of all or set of all real numbers. Again, take another example. And set of real number you can be written in this form. Set of or okay, set of real number can be written in this form. This is open interval minus infinity to infinity. It means all numbers between before infinity and minus infinity. Because it's an open interval, that's why both are not included. Real number also written in this form. Okay, again check f of what is domain of this function. Now clearly if you put here x is 2, then what we get?
Excuse me,
1
sir.
of g.
For a second, sir, अननोन पर्सन आया है, मतलब नाज़े पे बातें कर रहा है, उसको आप रिमूव कर दें.
कौन है ये?
सर तुर्क ऐसा कोई नाम.
एक मिनट.
Kordoglo Turk.
जी जी.
एक मिनट मैं अनम्यूट कर रहा हूँ. मैं एक मिनट अनम्यूट करता हूँ.
हेमंत सर तो जो है तो को भी कम हो जाए पर्सनल में मैसेज कयो.
ठीक है. Now you check f of x equal to 1 upon x minus 2. Okay. Now if x equal to 2, if you put x equal to 2, then what we get? F of 2 is 2 minus 2 0. 1 upon 0 is infinity. It means x equal to 2 is not domain of this function, because at x equal to 2 the function is infinity. According to the domain of the function, those values of x at which function is infinity is not domain of the function. It means 2 is not domain of the function. Again, you put any other value, maybe put 3. 3 minus 2 is 1. u5 minus 2 minus 2 minus 2 1 upon minus 4 not infinity, means all real numbers are the domain of the function except this number 2. It means what is domain? Thus f of x is finite for all real values of x except x equal to 2. Thus domain of this function is r minus, this r minus 2 means all real numbers except this number. Domain of this number, domain of this function, all real numbers except 2 removed from here. Okay, again another example, f of x equal to 1 upon x square minus 4. Now if here you put x value plus 2 or minus 2, then we get 1 upon 0 is infinity. F equal to 2 is 1 upon 0, and f of minus 2 is again 1 upon 0. It means because here is x square, you put 1 or 2 or minus 2, both are same. Thus f of x is defined for all real number of x except x equal to minus 2 and 2. Then domain of this function, all real numbers except minus 2 and 2. Again, see here in radical, now this is a function radical form. It means there is a chance of imaginary number. Now you see that if we put any number greater than or equal to 2, x is greater than or equal to 2, means if you put 2, 4 minus 4, 0, okay, 4 is okay. Again you put 3 means 9, this is also okay. If you put x is less than or equal to minus 2, then f of x is real. But if we say x equal to 1, then what we get? Radical minus 3. Radical minus 3 means minus 1 into radical 3, and minus 1 radical means iota. Minus radical 3 is minus iota 3. This is imaginary number. Similarly, x equal to 1.99, again imaginary, which is again imaginary. If x equal to minus 1, then radical 3 is again imaginary number. Okay, and x equal to minus 1.99, then again result is imaginary. We see that for any x in the interval, it means in the interval between minus 2 and 2, f of x is imaginary. 2 minus 2 nahi, between minus 2 and 2, if you put any value between minus 2 and 2, you get imaginary number. It means between minus 2 and 2 is not domain of this function. Domain of this function set of all real numbers except this interval. Again, f of x 1 upon radical x square. Here we see that if we put x equal to minus 2 or x equal to 2, f of x become infinity. It means x belongs to minus 2 and minus 2. The function is imaginary. Then domain of this function is r minus 2 and 2, and this is a closed interval. Domain of this function set of all real numbers except minus 2 to 2. These are the this is domain of the function. And okay, if you have any question, you can ask one by one. Yes, there.